Now, it deals with radical simplification, just simplification of radicals, so it's not too bad of a lesson. I am going to have to introduce some stuff, though, that's a little bit different this year. This is the square root of x squared y to the 10th. Now, a couple of you probably remember how to simplify that. What's square root of x squared? X. Okay, so you're saying equals x. Square root of y to the 10th. What times itself yields y to the 10th? Retro. What's that? Y to the 5th, kids. IXL won't accept that. It's not right. Technically, it's not right. It's never really been a big deal, and I always thought it was kind of silly, but it needs a set of absolute value bars on it. Here's the reasoning behind that. When you take the square root of a number, unless solving for x, isn't it positive? If somebody asks you what square root of 16 is, what do you say? You don't know. If they just ask you straight up what square root of 16 is, you just say 4. If they say x squared equals 16, that's when you say plus or minus. It's kind of one of those weird things about math. Like, why isn't it always true? It's just the way it is. That's about all I can really tell you. So unless solving for x, the result is always positive. I'm glad you remember plus or minus, but that only applies if you're solving for an unknown. If somebody asked me what the square root of 100 is, I'd say 10. If somebody said x squared is 100, that's when I'd say plus or minus. But by default, you only need the positive answer. So that's kind of why we encapsulate this thing in absolute value bars. And I'll try and explain it in words as opposed to the theorem. But when evaluating an even root being something like a square root or a fourth root, whatever, as long as it's an even root. If an odd quantity is pulled out, encapsulate in absolute value bars. If you pull out an even quantity, you don't have to worry about it. Because if you square a negative, what do you get? I pulled out an even, say I had an x squared out there. Would I have to worry about the possibility that that becomes negative? Answer to that question is no. I wouldn't. You can't really use a calculator to kind of show kids why this works because the calculator just doesn't quite do it properly. It wasn't quite programmed to handle absolute square roots entirely 100%. Correct. But there's the deal. You worry about this with even roots when you pull out what kind of quantities? Odd. If you look at the example that we did, we pulled out an x to the first, that's odd. We pulled out y to the fifth, that's odd. That's why I encapsulated in absolute value bars. You can go online, and I'm sure somebody will give you a nice, good, long explanation of why this is true. They won't use numbers, they'll just use theorems to do it. Now, did I talk about worrying about odd roots? No. We'll make a little note here. Don't worry about absolute value. Did I record? Okay, good. Go away. Don't worry about absolute value on odd roots. You don't have to worry about that because the cube root of a negative is negative. Cube roots allow that negativity. Even roots really do not. So it's basically last year's Algebra 2 lesson, and all we're doing is writing absolute value bars, kids. I honestly don't know of anybody in the state of Tennessee who teaches with absolute value bars, but I know it's in the standards. It was in the standards when I was a kid. It was mentioned, but the ACT doesn't worry about it. Even in the course tests, don't worry about it. It's just not deemed that big a deal, but whoever wrote IXL thinks it's a big deal. So there you go. May as well learn it 100% correct. So here's our first simplifications. We had our little warm-up example. What kind of root's that? Is it even or odd? That's a square root symbol, isn't it? If I zoom in on the right one. That even or odd? That's an even root. So we do need to be worried about absolute value bars. Now, when you were probably in Algebra 2, I probably told you just to put a little 2 outside. And then all you had to do was think about how many times does 212? 6. So that's a root. You pulled out x to the 6th. Itself, it was even. If you take a negative number and you put it to the 6th power, don't you get back a positive? There's no need to put absolute value bars on this. The even power guarantees positivity. It's guaranteed to happen. However, when you start focusing on y, how many times 214? 7. Now you don't know what these things are, but if by chance y was negative, even though you took a square root, if y was negative, this simplified result, the answer could potentially become what? It has to be encapsulated in absolute value bars. You pulled an odd piece from an even root. Anytime you pull an odd piece from an even root, you wrap in bars. That's all you do. It's really not that much different than anything you've done in the past. You just got to remember this little thing. Why don't you guys try and do the next one underneath? Or is that a cube root? No, I'll do the cube root. You guys can do the one under that. That's the cube root of x to the 8th. Sorry, cube root of x to the 15th, y to the 15th. It's a cube root. What do you know what to say about absolute value bars and cube roots? Odd roots. Don't worry, right? They say don't worry, so don't worry. I'll write that down again. Odd root, don't worry. Asia, what's the cube root of x to the 15th? How many times 315? So what's the cube root of x to the 15th? What to 5? X. You really do have a headache. Jaden, what's the cube root of y to the 15th? Y to the 5th. Anybody got any questions about that? Anyways, I want you guys to work on the one underneath. It's an even root. It is an even root. There might even be a little bit left over on the inside. And you may or may not need absolute value bars. It's left over, it stays inside.
No, you just keep it that way.
I'm going to go with yes.
So just keep her inside while it you leave it. While it
No, you can pull some of that away. You can pull some of it, yes.
and you write what's left over behind it.
This is mainly meant to just kind of see what you remember. How many times that 4 enter that 8? Twice, right? X squared. Anything left over? How many times 4 enter 11? Twice. Y squared. But there was stuff left over. 4 enters 11 twice with a remainder of what? Y cubed. Do I need absolute value bars on anything? No. Why not? Because these are evens. I only worry about absolute value bars when I got odds pulled outside and even roots. This is okay. Any of y'all get that right? I see at least one head nodder. I hope you got it right. Should. All right, we only got 2 more of this little section. Simplify the radical expression. As you move up, of course, they start introducing numbers because they want to make it a little harder. This is a cubed root. Lindsay, do I give a crap about absolute value on a cubed root? Why not? Because it's odd. Don't worry about it. It's odd. But we do have some numbers. If you guys have been doing this stuff by hand the last couple of days, you actually know what the cube root of 729 is. What was it? Nine. It was 9. It was 9 on every IXL lesson you did. I'm sure that number was in there at least once, unless you just lucked out and you didn't get to see it. But it's 9. Evaluate the number, it's 9. Haley Brooks, cube root of x to the 7th. Haley is evaluating the cube root of x to the 7th. Oh, kids. Okay, I'm glad I asked. The cube root of x to the 7th can be thought of as the cube root of x cubed, x. That's how you can think of it. You can break it apart. The reason I use 3's here is because there was a 3 outside. What is the cubed root of each x cubed? Well, the cube root of each piece is x, which will become x squared, and there's something left inside, an x. So this thing becomes x squared cube roots of x. That's how you think about those pieces. Or you can just simply think, how many times does the root enter the power? And we'll write that out since some of y'all are struggling with this. That's the shortcut. How many times does the root enter the power? I'm zoomed all the way out. No, I'm not. Remainder left inside. Anyways, back to my little example. We were able to pull out an x squared. I'm going to leave a little space before I rewrite that radical, because there's still a y to worry about. What was left inside that radical? X. So now we're on to the cubed root of y to the sixth. Miss James, what's the cubed root of y to the sixth? Huh? How many times 3 under 6? So what's the cubed root of y to the sixth? Y squared. There's your answer, kids. 9x squared, y squared, cubed roots of x. Annika, do we need to be worried about absolute value? Why not? Because it's an odd root. Really, that's simple. Is our next one even? It is even. It is even. So spend a minute, figure that sucker out, and then we'll go over it, and then we'll move on to the next section on IXL. Hopefully you guys didn't use calculators to do that one lesson that dealt with roots and exponents.
You know, like, my sister was having me help her with her homework the other night, and she was doing exponents, and it was like open parentheses, -4 squared, close parentheses, and she was getting frustrated because she was making like a, +16, and she was getting it wrong.
No, the even root and the exponent cancel.
And she was getting mad because I just did it in my head. I was like, it's going to be negative because you pull out that negative. And she was like, why? She's like, this doesn't make sense. She was getting so mad.
If you take the square root of a negative squared, it is actually negative. When you're dealing with legit numbers and you don't know what they are, you have to refer to absolute value bars. But when you're dealing with numbers, it stays negative. The powers cancel each other out.
Because if it's inside the parentheses, that'll make 2 -4 multiplied by each other, and then it'll be a positive 16.
It's one way of getting at it.
I don't think it makes sense either.
You have to rewrite it as an exponent. You have to rewrite it as an exponent. All right, on to this one. Emma, what's the 4th root of 16? 4th root of 16 is not 4. 4 times 4 times 4 times 4 is 512. I ain't even worried about the x's. I want to know what the 4th root of 16 is. It's 2. 4th root of 16 is 2. All right, we're moving on now to that piece with x's. Aaliyah, how many times that 4 enter that 7 on the x? Once. All right, I guess some of us are still struggling with this. So I'll put some words down here. 4 enters 7 once with a remainder of what? 3. So, the 4th root of x to the 7th, and in algebra 2, you could have wrote this, and I wouldn't have had a problem with it. You pulled an odd number of x's from an even root. What's that x need to be wrapped in? Absolute value, kids. Is the absolute value of x times the 4th root of x cubed. Because 4 won't enter that 3. And I don't know that I'm actually, well, yeah. Well, I'm going to put that x down. I'm going to leave a little space. I'm going to go back and look at this y piece. That's the 4th root of y to the 4th. Annika, what's the 4th root of y to the 4th? Y. Odd number, right? Pulled from an even root. Pulled y to the 1st. both x and y, what do they need to be encapsulated in? Parentheses. I don't think you need to put the 2 in a set of parentheses or a set of our absolute value bars because it's just the number 2. I don't know why you would. But those variables have to be encapsulated in absolute value bars. That's really all I got from that section. What you got? Nope, just stupid. No reason at all. Was probably looking at that.
Why'd you do 30 when Andrew's twice? Oh, yeah.
Which one is it? Yeah, no.
It enters it twice. 4 intersected twice.
No, honey, it does not.
What is 4 is 8?
4 times 4 is 16. 4 times 2 is 8.
I'm confused. Where does the 3 come from? 4 plus 3 equals 7.
Well, that's one way of looking at it.
Oh, that's what
Yeah, it's a remainder.
Okay.
Sounds like y'all need to spend about 40 minutes doing that section. Till it clicks. Next up is a section that works with numbers. It's multiplying radical expressions. Multiply and write your answer in simplest form. Now, this section is actually a lot easier if you'll factor the numbers first. It is. It's my suggestion that you factor the numbers first. And what you're doing is you're kind of relying on a theorem. I don't know that you have to know it, but the square root of some a times b is the square root of a times the square root of b. It's a little property that allows you to work 2 directions here. You can either take 2 radicals and multiply them together and put them together under a radical, or you can break it apart. This section's kind of working left to right, the other way around, that we can actually multiply radicals together. But I suggest you factor the numbers first. What are factors of 15? 3 and 5. And your calculator is not going to be able to just answer this question. I'm sure there's an app on Google that will. You won't learn a darn thing if you sit there and rely on Google. Does 5 happen to enter 195? Sure, of course it does. If it ends in a 5, 5 enters it. How many times 5 enter 195? $39, is that what I heard? That's pretty good. What's 39 divisible by? 13 and? There we go. That's worth writing out. I factored the number first. The reason I did that. So I wrote out the factors of those radicals. Now I'm actually going to multiply them together. And I'm not going to worry about what the number on the inside is. I don't care what the number is on the inside. I really do not care. I can put those 2 separate radicals under one distinct radical. And I'm going to line like pieces up. I got a 3 and a 3, don't I? Isn't 3 times 3, 3 squared? Who cares about what the number of the result is? It's 3 squared. Don't I have a 5 times a 5? I do. It's 5 squared. Now I got this 13 left over. I'll show you why I'm thinking this way as opposed to just typing things in on a calculator. What's the square root of 3 squared? 3. How about the square root of 5 squared? 5. What's left inside? 13. Now notice when I evaluated a piece, I just brought it out through multiplication like we did in the previous section. What's 3 times 5? Now, the reason I'm doing this is because the alternative for most people would have been to go to your calculator, and you know full well, like if you made it through Algebra 2, regardless of Corona shutting us down, if you thought you could type stuff like this in and get a result on your calculator, you didn't pay a lick of attention in class, ever. But most kids would figure out what 15 times 195 is, and they get that big old number. Would it occur to you that that thing is divisible by 225 right off the bat? It wouldn't have occurred to me either, but it is. What's the square root of 225? Let's go with 15, like we have in front of that radical. If you approach these things and just start putting pieces together, you're going to have a harder time than breaking it apart and putting it together from the get-go. But what do I know? So you'll do a couple with numbers, and then they'll level you up, and you'll do something where we have numbers and radicals, or sorry, and variables. And nothing in this particular section, for some reason, worries about absolute value bars. So you have the one section where they try and reinforce absolute value bars, and then that's it. On this one, nothing in your instructions talks about absolute value bars. You don't have to worry about them. Previous one talks about it. So multiply and assume m is greater than or equal to 0, which is why you don't have to worry about absolute value bars. And write your answer in simplest form. Before I do anything, I'm going to break apart that 147. What are your factors of 147? There's usually a hint in the first one. Usually one of the other radicals gives you a hint. See that 3? That's a hint. How many times 3 under 147? How many times? 49. Now it's broke apart. Now I'll worry about putting it together. How many 3's do you have? You got a 3 here, you got a 3 here, you end up with a 3 to what power? Second. Then you got that 49, which you should know what that is. I'm not going to write 7 squared. You should know what that is. You don't know what the square root of 49 is, kids. You need to hurry up and start memorizing things. What's m to the 4th times m cubed? Or you can just leave it m to the 4th m cubed. I don't care. Isn't it m to the 7th? Yeah? You're supposed to add exponents together? Now let's start evaluating. Square root of 3 squared. 3. Square root of 49. 7. How many times is that understood 2 enter 7? 3 times, m cubed. There was a remainder though, wasn't there? Where's the remainder go? Under the radical. You cannot throw that thing away. By the way, no, you can't just add those pieces together. Never mind. Finish the multiplication. Everything outside the radical is implied to be multiplication. 3 times 7 is 21. And this section doesn't care about absolute value bars because they tell you that variable is positive from the get-go. So it doesn't worry about it. Now, anybody got a question on that? I'm hoping you guys will actually do enough of these by hand and radical simplification won't be a problem. One can hope. We got another square root. Oh yeah, these are about as hard as this section gets. We have 8 times 98z cubed times the root of 7y cubed. I reckon we should probably try and break up 98. Give some factors in 98. 2 and what? $49, kids. 49 is a good one. Why is 49 a good number? Square rootable? No. Can't break up 7. And you can go ahead and merge things together under one radical if you'd like. That's kind of optional. After a while, you don't really do that. I'm just trying to show everything. So that's kind of what it looks like. Now, I didn't write 49 as 7 times 7 because I'm taking a square root. I should know the root of that 49. The root of that 49 being what? 7. So I pull that out. It's multiplied by the 8. The numbers left inside are a 2 and a 7. Square root of z cubed. Man, I didn't leave enough room. Hold on. I need more room there. Numbers inside are a 2 and a 7. Can't take the square root of either one of those. Square root of z cubed. A z outside, and what's left inside? A z. Square root of y cubed. A y on the outside because 2 enters 3 once. A y on the inside. Then all you gotta do is clean things up. That's 7 times 8. You memorize that in 4th grade just like I did. 56. 56. zy or yz. I like yz better. Alphabetical order. What's left in the radical? 14. And I'm going to do yz. I like alphabetical order. And I'm going to stop there on that, and I'm going to move on to M8. You don't see this until you get into the mid-90s. Which you should try to do. You really should. All right, M8 is about radical simplification. And we're not solving for variables, so all our answers are positive. It does say simplify, which might be a big deal on some of these examples, and we'll talk about that when we get to it. Radical simplification relies on this property right here. The square root of a over b can be rewritten, and I made you memorize this no matter what year you took me. How can you rewrite the root of a over b? Actually, I may not have made you memorize this one. Probably should have. How can you write the root of a over b? Yeah, you just break it apart. It's just a break apart rule. That's all it is. So when I look at the root of 49/4, I don't worry about what the number is. I don't give a crap that it's 24.5. I break it apart. And I may not show it on paper, but that's how it's thought. So what is the root of 49/4? 7/2. The root of 49 is 7, root of 4 is 2. Now, when I look at the next one, the root of 20 over 45, there's no real root of 20, is there? Is there a real root of, well, there is a real, it's real. But is there a whole root of 20? Is there a whole root of 45? So simplify. Huh? Maybe, I don't know. I was thinking about the numbers themselves. What do they both have in common? They both have a 5 in common. So I have a 4 times a 5 in the numerator. And I have a 9 times a 5 in the bottom. You understand that? Just simplifying the numbers is what I'm doing. You don't have to simplify at the end. A lot of times, if you simplify in the beginning, the end result is easier. Now, what do those 5s do to each other? Cancel out. So it looked like the root of 20 over 45 was really the root of 4 over the root of 9. Simplify first, kids. It usually pays off. What's that reduce to? 2 over 3. Be thinking about that. Make a little note. Try and simplify first. Now, had you done with what Haley was talking about, Haley said that this was 2 roots of 5, and the bottom piece would become 9 roots of 5. Sorry, 3 roots of 5. I'm not going to go behind the math behind that, but that's what it would have been. Then you could have canceled those out. Mentally, I think this is harder. I do. But I'm not you, so I don't know. I don't know why I've got that result in. Weird. We've already done 2 of these, so those don't matter to us anymore. Why don't you guys take a shot at this one? Try and simplify that root 147 over 4. I know you're bored. I know it's been a while, but we already worked with 147 once. I got left in these notes. Anybody got an answer? What'd you come up with? Oh, I agree. There's So Emily decided that 147 was the root of 3, or was 3 times 49. Bottom's root of 4. Keep going. Where's the 7 go? No. You evaluated that piece. If you evaluate it, it's no longer inside. If you just sat around and did the root of 49, would it be under a radical?
No.
So where does it have to go? Outside of the radical. What's left in? 2. Evaluate your pieces, kids. Why don't you guys take a shot at that one? I want to see if you remember something. That one. I want to see if you remember something. I guess I may not finish today. Too much too. I'm gonna wait enough for actual waiting, but kind of far. Going the way, it's root 4. Well, you kind of wrote this wrong. This is actually root 4 times 2. Root 4 is 2. It's that radical stuff too. Well, a handful of you remember what to do. This one didn't lead itself to just being simplified from the get-go. I saw some break aparts. I saw root of 9 over root of 8, which I liked. I saw the root of 9 being written as 3. A couple of y'all weren't thinking about this root of 8. Root of 8 is the root of 4 times 2. What's that root of that 4? So that's 2 roots of 2. Now, what's the problem with this number? Radical in the denominator. About 4 of you remembered the correct process. How can I write this out in words so it doesn't conflict with another one? It's just a radical. It's not a complex number, so I can actually use the word radical. If a radical only, it is kind of only, it's 2 times that radical, exists in the denominator, I would say we rationalize it, but whatever. Multiply numerator and denominator by the radical. Now, 2 of you tried doing too much work here. That's normal, and you wouldn't have got the wrong answer. You still would have got the right answer. Just would have had to do a little more work to get it. The radical itself is a root of 2. That's what I multiply the top and bottom by. When you multiply by a root of 2 over 2, you are not changing the value of the number because you're really just multiplying it by what? Root of 2 over root of 2 is 1. You are performing cosmetic surgery. Nothing more. You're making it look different. Still the same number. Anyways, up top we have 3 roots of 2. Sorry, yeah, 3 roots of 2. 3 times root of 2 is 3 roots of 2. Down low, we got to kind of focus on this piece. That's a radical times itself. What's radical times itself? Number inside. Root of 2 times root of 2 is root of 4. Root of 4 is 2. There was a 2 out front. Root of 2 times root of 2 is 2. Twice 2 is 4. 3 roots of 2 sitting over a 4. That's your final pretty answer. I know a couple of you seniors, you guys kind of took a year off of doing things in your head. Because dual enrollment's done primarily in a calculator, isn't it? I don't know what to tell you. Because you can use a calculator doesn't mean you always should. Oh, well, you had it made. You got to use a calculator in stats. I didn't. We do it all by hand. Way worse. I guess I'll start here tomorrow. I was hoping I'd get more done.
So if I finished everything under the free calculation on IXL, and then I did the other 2 on the algebra 2 that we were supposed to do. So is everything, is that all covered?
I believe I can pull you up. I don't know. Let me give you a count of how many things I've assigned. Oh, I actually put quite a bit. You guys actually have quite a few grades. I might have to revamp the grading policy to be weighted more towards homework because I haven't given hardly any quizzes.
But one of them, I think, because I was behind, and then that Friday, I think you graded and stuff, and I wasn't done with one of them, and so it said like a 50 something on it. But I redid it. So I went back and finished it.
This doesn't include this stuff that I'm talking about, Dave. It looks like I've assigned 16 things on it, so.
Yeah, I've done all the ones that are pre-calculus. I did 2 under algebra 2. I've not started on the other ones under algebra 2 yet. I didn't watch the videos, but the stuff on IXL I did, I remember.
Thanks a lot. Y'all enjoy your day.
Kind of, but then I like Googled some stuff to remind myself, and then Dad helped me. Because my laptop was out of date, so I couldn't, your videos would not play for some